The force of friction is the force that resists two surfaces sliding past each other. There are so many applications of this, and you experience it all the time. So I'm pretty sure that you know what the force of friction is, but we're going to use it in a whole bunch of different applications. So imagine, first of all, just any two surfaces. Friction is what prevents them from sliding past each other like this. So that could be you walking along the floor. So friction is what keeps your shoes from sliding on the floor. Think about wheels rolling. So friction is what keeps your wheels actually moving your vehicle or your bicycle along the ground. If there was no friction, your wheels would just spin there. Friction is also what we're trying to minimize in wheel bearings so that the energy from your engine moving your wheels can move them as efficiently as possible. So when you're driving or when you're riding a bike, we're both trying to maximize and minimize friction in different ways. So our formula for friction is as seen here. This is the force of friction, and as with every force, it is in newtons. This strange letter over here is the Greek letter mu, and that's spelled like this, or at least it's read like that, mu, mu, and it is the coefficient of friction. It's basically a number that tells you how easy or difficult it is for two surfaces to slide past each other. So the coefficient of friction for new tires on a dry asphalt road is very high, 0.9 something. Okay, so that would be a high coefficient of friction. But it's easy to slide, say, an ice block across an ice surface. So the coefficient of friction between ice and ice is very low, maybe 0.01 or something like that. But it's almost always going to be between 0 and 1. Almost always. Every once in a while there's a certain type of material on another certain type of material that will get you above 1, but we really won't deal with that very often. So you can keep that in mind when you're solving problems. If you get answers that are outside of the 0 to 1 range, they're probably not correct. This Fn over here, we've talked about it very briefly, but we haven't really studied it much. And it's the normal force. That's also in newtons. Okay, and the normal force, if you recall, is the support force that a surface exerts on an object. So if you had a surface like this, and here's your object, the normal force would be pushing upward on the object. Normal means perpendicular. And so notice that this force is perpendicular to the surface. But if you had an angled surface like this, the normal force would be pushing like that, perpendicular to the surface. And so how much friction there is acting on an object depends on how much normal force there is pushing against that object. And so you might have noticed before that really, really heavy objects tend to have more friction acting on them. And that's why it's difficult to, say, push a car. Or if you've ever tried to move furniture, it's important to put something underneath the feet. If you can't lift the furniture, it's important to put something underneath the feet that reduces the amount of friction. So there's these little plastic pads or felt pads that allow you to slide it along the floor. But if you don't do that, and you'll have a large amount of friction, and the heavier the furniture, the more difficult it is to move because friction acts on it more. But why don't we just say the force of gravity then, right? If a heavier object, if it's about how heavy the object is, why not just gravity instead of the normal force? Well, it depends on the angle of the surface. So if you have a surface like this, and you put an object on it, the amount of friction on that object is actually going to be less than if you had a perfectly horizontal surface. And so we need to use the normal force because that takes into account what the surface is doing. Okay? For our purposes in grade 11 physics, all of our surfaces will be horizontal surfaces. And so they are interchangeable for us. The force of gravity and the normal force, you can just substitute in the force of gravity instead of the normal force whenever the surface is horizontal. And again, in grade 11 physics, we deal with horizontal surfaces. So, some things about the coefficient of friction. It tells us how difficult it is for two surfaces to slide past each other. So we just said that a higher number means greater friction. So 0.9 would mean that the two surfaces are much more difficult to slide past each other than 0.1. And the coefficient is almost always less than 1 and almost always greater than 0. It's never negative. We can say that. It's almost always less than 1, and it's always greater than 0. And here's where we talk about that difference between the normal force and the force of gravity. If you have an object that is on a level surface, like this, it's a wavy surface, but it's a level surface, then the normal force is pushing straight up, normal force, and the force of gravity is pulling straight down. And because this object is not being tossed up off of the surface or sucked through the surface, we know that the normal force and the force of gravity must be equal to one another. They must cancel one another out because this box has no acceleration in the up or down plane. And so we can say that F net equals ma, because that's always true. And in this case, the a, this part over here, is 0, right? Because there's no up or down acceleration. And so when we put in this Fn plus Fg, it equals 0, because mass times 0 is just 0. And so we know that the normal force is equal to the opposite of the force of gravity. So they're the same size, it's just that one is up and one is down. But when we're putting it into the friction formula, we don't really need to put in this negative over here, because the fact that the normal force is up really doesn't have anything to do with the direction of the force of friction. The force of friction is not going to be in the same direction as the normal force, or in the opposite direction as the normal force. It's going to be perpendicular to the normal force. And so that negative doesn't really have anything to do with the direction of the force of friction, so we don't need to include it. So we have two types of friction, depending on the situation you're in. You've got static friction and kinetic friction. Static friction is for objects that are not moving. So that seems a little bit odd at first, but now think about you've got a really heavy object on the floor and you're trying to push it, but you're not strong enough. What's preventing you from pushing it? It's the force of friction. The force of friction is too great for you to overcome with even your massive strength, and so then the object remains not moving. Okay, so static friction will always have a higher coefficient than kinetic friction. So think about this. If ever you've been in the situation where you are trying to push a car that's been stuck somehow, it's really difficult to get it to start moving, but once you've got it moving, then it's easier to keep it moving. Okay, so what happens is you are experiencing a higher coefficient of friction in order to start the object moving when you've got static friction acting on it, and then once it is moving, kinetic friction takes over and the coefficient for kinetic friction is lower, and so it's easier to move. Okay, so when you want to start an object moving, you will need to overcome the force of static friction. So when your applied force, or whatever force is trying to make it move, becomes even a hair greater than the force of static friction, then it will start to move. For kinetic friction, this is for when objects are moving. Objects in motion. When an object is in motion, it is also experiencing the force of friction in some fashion. It's just that it's going to be less friction than when it was static, when it was not moving. So you get a lower coefficient. And if you want to keep an object moving without slowing down, you must meet or exceed the force of kinetic friction. That's to keep an object moving.